Let's have a look at some more cubic graphs. So two things we want to do is one, from the graph, work out the equation of the cubic. And secondly, being able to sketch a cubic from an equation. So look, here's a really basic looking, or two actually. There's the blue cubic and the red cubic. So let's start with the blue cubic and work that one out. So what we need to do is we need to work out, okay, where does it intersect the x-axis? So we're here, there, and there. So it's at 0, 4, and 6. So from that, because it's 0, we write that there, 4, x minus 4, and 6, x minus 6. And that's all we need to do. Okay, that's it, finished. So it's pretty quick, but it's really recognizing where those x-intercepts are. And as a check, you can have a look and see where does it intersect the y-axis, but this one passes through 0. So we can't check if there's been a scale change or anything like that. And we're not worrying about scale changes anyway, so you can just ignore that comment for now. So there it is. The other thing to note is it is an upright parabola, so it's positive tending. So as we move from left to right, you can see that that parabola tends in a positive direction. So therefore, if I expand the whole thing out, I should get a positive x cubed. And we do, and you can see that here because x times x times x gives me positive x cubed. Okay, so I don't know what else to say about it. Notice that we're not interested in where the vertices are, and where's this point or that point. It has no bearing on the equation itself. Right, let's look at the next one then, and go ahead and do the red one. So I'll use the red pencil because there it is there. Now, first thing to notice is that this, where the other one was a positive tending cubic, this one is a negative tending cubic, which means that its highest power, or its x cubed power, is going to be negative. But we do the same thing. So let's have a look and see where actually, and just get rid of these for the moment then. Where does it, whoops, too much that one. Where does it intersect the x-axis? So let's find those points. It intersects the x-axis at 1 and at 4. No, it doesn't. That's at 3 and at 5. All right, well, from there, we're good to go. So we can go y equals, that's going to be x minus 1, x minus 3, and x minus 5. Now, we're not quite there yet. We're nearly there. I need to make a little bit of room, which I can do over here. And I go y equals, because it's negative tending, it needs to have a negative in front. All right, and that's the equation of it there. We note the x-intercepts, x minus 1, x minus 3, x minus 5, and it's negative tending. Sometimes these graphs are also written like this, where we multiply that negative through by one of the brackets, and then it becomes 1 minus x, x minus 3, x minus 5. Those two equations are the same. That first bracket has been multiplied through by negative 1. Often you'll see them there, and just be careful with that. When you're sketching it, that you recognize that we are going to get a negative cubic there, because that's negative x times positive x times positive x, all multiplied together gives me a negative x cubed, and therefore we get that negative tending thing. Now, both these graphs are in this form where I've got y is equal to x minus a, x minus b, x minus c, where A, B, and C are the x-intercepts. Okay, nice. Right, next one. Let's say we're asked to sketch this. Okay, let's say we've got sketch y is equal to x plus 1. Got the extra bracket there for some reason. X minus 2 and x minus 3. We'll set up some axes. We'll do that here. And here, it's big enough. Y-axis, x-axis. And I should notice that this actually is a positive tending cubic because that's positive, and that's positive, right? So there's no negative there. So that's nice. And we're just looking for intercept. So I've got an intercept at -1 from that one. +2, we'll make that 2, we'll make it -1. And then 3, we've got it there. And that's enough to sketch that through. The other thing is we need to know what the y-intercept is. So the y-intercept is we multiply, oops, I think I've just deleted some stuff anyway. We need to multiply this 1 by -2 by -3, which gives me +6. If I count up there, 1, 2, 3, 1, 2, 3, I've got the +6 there. So it goes through there, nice and high. So if I go ahead and sketch this, which I can, pass through that point, pass through there, comes back down and does that thing there. Notice that when we're sketching the graph, look, it could be there, it could be a bit higher, could be a bit lower, same here, could be a bit higher, could be a bit lower, but you get a feel for it, okay? So it's just a matter of drawing a smooth cubic curve through that thing. The most important thing is that we've got the intercepts correct at -1, 2, and 3, got the y-intercept correct, and we've got the shape of the parabola correct as well, and that it's a positive tending cubic. Let's do another one, okay? So we can probably squeeze it in on the same graph. I'll put one over here, not green, blue. Come on, blue, blue. So I've got y is equal to, and here I've got x squared times x minus 5. Right, now, because of that square, we've got something a little bit different going on. And if you watch the previous video, you would know what that is. And that, first of all, the x indicates that it's 0, but the square means it touches at 0. The other point is 5, so I've got it sort of going over there. It means I've only got 2 points. The other annoying thing, well, it's not annoying, is that the y-intercept is 0 as well. Because as soon as that x is 0, then 0 times -5 is also 0. So those are the only 2 points I've got to work with. So we're going to check, is it a positive tending or a negative tending cubic? Well, if I multiply all the x's out, I get a positive x cubed. X squared times x is x cubed. I get a positive x cubed. So I know it's going starting low, finishing high. So if I go ahead and sketch this, it's going to look something like this. I'm going to start low. It hits that x, and remember it touches at that point. So we're going to go down, and then we're going to go through. So there it is there. We've got, so it passes through 5, but it touches at that particular point. Let's do another one. We're having fun. So let's say I've got x, here's a really, really tricky one, all right? I've got 3 minus x times x minus 1 squared. And I'll, because this is so nice, oops, we'll get a new set of axes for it to sketch that one. So set of axes, x-axis, y-axis, each square is 1 unit, and we're ready to go. Now I'm hoping that what you can see is that because I have got this thing over here, it's actually a negative tending cubic, all right? Because if I multiply through the x's, so I'm going to get negative x times x again, because it's squared, I get negative x cubed. All right, so it's a negative tending cubic. The other thing is that I've got this power of 2 over here. So that means at the x-intercept of 1, all right, that actually touches at that point. And the other point is 3. So that's out here, 1, 2, 3. So it doesn't touch at that point. Now it's a negative tending cubic. So we can multiply out and see what we get for the y-intercept. So 3 times -1 times -1, because it's squared, right, is +3. So there it is there. So it's not too bad. And you should recognize then that it's going to touch at oops, it's going to touch at say this how many times, touch at 1 because of this thing over here. Okay, it's got a square on it, and pass through 3, but be negative. Now, because we've got a y-intercept, it sort of forces it that way anyway. All right, down, touch it 1, up, and pass through 3. And I did a really bad job of that because I missed that 3 point altogether. Supposed to pass through that. We'll do it again. Not that it matters too much. You got the idea. So here we go. Through this time, touch at this point, up a little bit. And that's a really wonky cubic, but you get the idea. So let's have a look at it, make sure we understand what's going on. So it's going through y equals 3. There's 1, there's 3. And remember, because of that square, it touches at that point. And that's very nice. We'll leave it right there.